CodeFusion, a pre-trained diffusion model for code generation. Imagine a developer who can only change their last line of code. How often would they have to start writing a function from scratch before it is correct? Auto-regressive models for code generation from natural language have a similar limitation. They do not easily allow reconsidering earlier tokens generated. We introduce CodeFusion, a pre-trained diffusion code generation model that addresses this limitation by iteratively denoising a complete program conditioned on the encoded natural language. We evaluate CodeFusion on the task of natural language to code generation for Bash, Python, and Microsoft Excel conditional formatting, CF rules. Experiments show that CodeFusion, 75M parameters, performs on par with state-of-the-art auto-regressive systems, 350 M175B parameters, in top 1 accuracy, and outperforms them in top 3 and top 5 accuracy due to its better balance in diversity versus quality. FP8LM, training FP8 large language models. In this paper, we explore FP8 low-bit data formats for efficient training of large language models, LLMs. Our key insight is that most variables, such as gradients and optimizer states, in LLM training can employ low-precision data formats without compromising model accuracy and requiring no changes to hyperparameters. Specifically, we propose a new FP8 automatic mixed precision framework for training LLMs. This framework offers 3 levels of FP8 utilization to streamline mixed precision and distributed parallel training for LLMs. It gradually incorporates 8-bit gradients, optimizer states, and distributed learning in an incremental manner. Experiment results show that during the training of GPT-175B model on H100 GPU platform, our FP8 mixed precision training framework not only achieved a remarkable 42% reduction in real memory usage, but also ran 64% faster than the widely adopted BF16 framework, that is Megatron-LM, surpassing the speed of NVIDIA Transformer Engine by 17%. This largely reduces the training costs for large foundation models. Furthermore, our FP8 mixed precision training methodology is generic. It can be seamlessly applied to other tasks such as LLM instruction tuning and reinforcement learning with human feedback, offering savings in fine-tuning expenses. Our FP8 low-precision training framework is open-sourced at the project's website. ControlLLM, augment language models with tools by searching on graphs. We present ControlLLM, a novel framework that enables large language models, LLMs, to utilize multimodal tools for solving complex real-world tasks. Despite the remarkable performance of LLMs, they still struggle with tool invocation due to ambiguous user prompts, inaccurate tool selection and parameterization, and inefficient tool scheduling. To overcome these challenges, our framework comprises 3 key components. 1. A task decomposer that breaks down a complex task into clear subtasks with well-defined inputs and outputs. 2. A thoughts-on-graph (TOGI) paradigm that searches the optimal solution path on a pre-built tool graph, which specifies the parameter and dependency relations among different tools. And 3. An execution engine with a rich toolbox that interprets the solution path and runs the tools efficiently on different computational devices. We evaluate our framework on diverse tasks involving image, audio, and video processing, demonstrating its superior accuracy, efficiency, and versatility compared to existing methods. ZeroNVS, zero-shot 360-degree view synthesis from a single real image. We introduce a 3D-aware diffusion model, ZeroNVS, for single-image novel view synthesis for in-the-wild scenes. While existing methods are designed for single objects with masked backgrounds, we propose new techniques to address challenges introduced by in-the-wild multi-object scenes with complex backgrounds. Specifically, we train a generative prior on a mixture of data sources that capture object-centric indoor and outdoor scenes. To address issues from data mixture such as depth-scale ambiguity, we propose a novel camera conditioning, parameterization, and normalization scheme. Further, we observe that score distillation sampling, SDS, tends to truncate the distribution of complex backgrounds during distillation of 360-degree scenes and propose SDS anchoring to improve the diversity of synthesized novel views. Our model sets a new state-of-the-art result in LPIPS on the DTU dataset in the zero-shot setting, even outperforming methods specifically trained on DTU. We further adapt the challenging MIPNERF 360 dataset as a new benchmark for single-image novel view synthesis and demonstrate strong performance in this setting. Our code and data are available at project's website. Personas as a way to model truthfulness in language models. Large language models are trained on vast amounts of text from the internet, which contains both factual and misleading information about the world. Can language models discern truth from falsehood in this contradicting data? Expanding on the view that LLMs can model different agents producing the corpora, we hypothesize that they can cluster truthful text by modeling a truthful persona, a group of agents that are likely to produce truthful text and share similar features. For example, trustworthy sources like Wikipedia and Science usually use formal writing styles and make consistent claims. By modeling this persona, LLMs can generalize truthfulness beyond the specific context in which each agent generated the training text. For example, the model can infer that the agent Wikipedia will behave truthfully on topics that were only generated by Science because they share a persona. We first show evidence for the persona hypothesis via two observations. 1. We can probe whether a model's answer will be truthful before it is generated. 2. Fine-tuning a model on a set of facts improves its truthfulness on unseen topics. Next, using arithmetics as a synthetic environment, we show that language models can separate true and false statements and generalize truthfulness across agents. But only if agents in the training data share a truthful generative process that enables the creation of a truthful persona. Overall, our findings suggest that models can exploit hierarchical structures in the data to learn abstract concepts like truthfulness. Data-centric financial large language models. Large language models, LLMs, show promise for natural language tasks, but struggle when applied directly to complex domains, like finance. LLMs have difficulty reasoning about and integrating all relevant information. We propose a data-centric approach to enable LLMs to better handle financial tasks. Our key insight is that rather than overloading the LLM with everything at once, it is more effective to pre-process and pre-understand the data. We create a financial LLM, FLLM, using multitask prompt-based fine-tuning to achieve data pre-processing and pre-understanding. However, labeled data is scarce for each task. To overcome manual annotation costs, we employ abductive augmentation reasoning, AAR, to automatically generate training data by modifying the pseudo-labels from FLLM's own outputs. Experiments show our data-centric FLLM with AAR substantially outperforms baseline financial LLMs, designed for raw text, achieving state-of-the-art on financial analysis and interpretation tasks. We also open-source a new benchmark for financial analysis and interpretation. Our methodology provides a promising path to unlock LLMs' potential for complex real-world domains. PockEngine, sparse and efficient fine-tuning in a pocket. On-device learning and efficient fine-tuning enable continuous and privacy-preserving customization. For example, locally fine-tuning large language models on personalized data. However, existing training frameworks are designed for cloud servers with powerful accelerators, for example GPUs, TPUs, and lack the optimizations for learning on the edge, which faces challenges of resource limitations and edge hardware diversity. We introduce PockEngine, a tiny, sparse and efficient engine to enable fine-tuning on various edge devices. PockEngine supports sparse backpropagation. It prunes the backward graph and sparsely updates the model with measured memory saving and latency reduction while maintaining the model quality. Secondly, PockEngine is compilation first. The entire training graph, including forward, backward, and optimization steps, is derived at compile time, which reduces the runtime overhead and brings opportunities for graph transformations. PockEngine also integrates a rich set of training graph optimizations, thus can further accelerate the training cost, including operator reordering and back-end switching. PockEngine supports diverse applications, front-ends and hardware back-ends. It flexibly compiles and tunes models defined in PyTorch/TensorFlow/JAX and deploys binaries to mobile CPU/GPU/DSPs. We evaluated PockEngine on both vision models and large language models. PockEngine achieves up to 15 times speedup over off-the-shelf TensorFlow, Raspberry Pi. 5.6 times memory-saving backpropagation, Jetson AGX Orin. Remarkably, PockEngine enables fine-tuning LMAV27B on NVIDIA. Jetson AGX Orin at 550 tokens per second, 7.9 times faster than the PyTorch. Reconstructive Latent-Space neural radiance fields for efficient 3D scene representations. Neural radiance fields, NRFs, have proven to be powerful 3D representations, capable of high-quality novel view synthesis of complex scenes. While NRFs have been applied to graphics, vision, and robotics, problems with slow rendering speed and characteristic visual artifacts prevent adoption in many use cases. In this work, we investigate combining an autoencoder, AE, with a NRF, in which latent features, instead of colors, are rendered and then convolutionally decoded. The resulting latent space NRF can produce novel views with higher quality than standard color space NRFs, as the AE can correct certain visual artifacts, while rendering over 3 times faster. Our work is orthogonal to other techniques for improving NRF efficiency. Further, we can control the trade-off between efficiency and image quality by shrinking the AE architecture, achieving over 13 times faster rendering with only a small drop in performance. We hope that our approach can form the basis of an efficient yet high-fidelity 3D scene representation for downstream tasks, especially when retaining differentiability is useful, as in many robotic scenarios requiring continual learning. Large language models as generalizable policies for embodied tasks. We show that large language models, or LLMs, can be adapted to be generalizable policies for embodied visual tasks. Our approach, called Large Language Model Reinforcement Learning Policy, LLARP, adapts a pre-trained frozen LLM to take as input text instructions and visual egocentric observations, and output actions directly in the environment. Using reinforcement learning, we train LLRP to see and act solely through environmental interactions. We show that LLARP is robust to complex paraphrasings of task instructions and can generalize to new tasks that require novel optimal behavior. In particular, on 1,000 unseen tasks, it achieves 42% success rate, 1.7 times the success rate of other common learned baselines or zero-shot applications of LLMs. Finally, to aid the community in studying language-conditioned, massively multitask embodied AI problems, we release a novel benchmark, Language Rearrangement, consisting of 150,000 training and 1,000 testing tasks for language-conditioned rearrangement. Video examples of LARP in unseen language rearrangement instructions are at the project's website. A framework for automated measurement of responsible AI harms in generative AI applications. We present a framework for the automated measurement of responsible AI metrics for large language models and associated products and services. Our framework for automatically measuring harms from language models builds on existing technical and socio-technical expertise and leverages the capabilities of state-of-the-art language models, such as GPT-4. We use this framework to run through several case studies, investigating how different language models may violate a range of responsible AI-related principles. The framework may be employed alongside domain-specific socio-technical expertise to create measurements for new harm areas in the future. By implementing this framework, we aim to enable more advanced harm measurement efforts and further the responsible use of language models.